Let's say if we want to convert from one base period to another using what I just explained, the ENR BCI, the Building Cost Index. So let's say we want to convert costs from 1967 to 2013. So if we say that the cost index, the BCI, for the year 2013 is equal to 5317. And the base cost that we're trying to compare the 2 years with, let's say the BCI for the, I mentioned the 1967, so let's use that for an example, is that constant package was 676. So the question I will ask you based on that, have the cost increased or decreased since 1967, and by how much? So basically, it is as simple as to say that the index on the 1967 base would be this amount or this index divided by this index. So if we divide both over each other, you will give you here around 786.5%. I think this is 8. So 786.5 approximately. Then from this simple question, we can say that index on the 1967 base, this over this, in 2013, the cost increased by more than 787%. So this is just like basic example, but let's now take another example to show how we can connect this with the construction and estimating a construction project cost. Here is another example. We are focusing based on a cost index. So let's say we have a warehouse that will be built in November in 2013, and we assume that you have an estimate for a very similar warehouse project that is completed in 1978 for a cost of 4.2 million back then. And we'll ask you what is the estimated cost for the new warehouse if we have a lot of similarities in both warehouses. So what I would say is that I would look at the publications and we find what is the cost index, the current one or the one in the time we want to build the house, which is 2013 in November. And we found it is 5,317. And then we look at the base cost index, we call it, as I mentioned in the previous example. And the base cost index in 1978 was 1,674. So based on that, an estimated cost for building the warehouse would be the 5,317 divided by the base of 1978 times the 100%, so you have kind of an increase on that constant package of these four components that I was talking about of around 318%. So the 318%, you multiplied by the 4.2 million to get an approximation of $13.34 million to build similar warehouse that got built in 1978 and you want to build it in 2013. So this is a quick example about how to use the cost indices or the cost index using the BCI in this question here, and in a very direct way. Okay, so moving forward, for the cost indices, I also want to highlight there is a limitations for this specific tool or method. There is one, unconsidered factors and project differences. What we mean by the unconsidered factors, it's some indices are based on input components, do not consider factors such as productivity and changes in technology. Indices do not also consider competitiveness of contractors and similar factors like that. Last but not least, it's also very important to recognize the geographic and demographic bases. For example, in the BCI I just explained, it's each component from the 4 components, from the lumber, from the steel, from the cement, from the labors. There is a 20 city average costs. But if you want to go specifically on an area in a metropolitan area, let's say New York or Chicago, comparing to a suburbs in another state, it will then vary considerably. So to consider the geographical and the demographic basis is very important, instead of just taking the average of 20 cities in the US. Also, project differences. Differing resource proportions, this is one main limitations. And what we mean by differing resource proportions is the following. There will be problems if the proportions of the input components in an input type cost index do not reflect the resource proportions in the projects in the question. And I gave you an example between the building cost index from ENR, the BCI, and the construction cost index of ENR, the CCI. They have a different numbers in the labor component, and sometimes these proportions in each of these components is different than the same items in the project itself. So differing resource proportion. Also, in project differences, it's common sense to look at one main limitation: differing projects. So problems if the projects which the index is based on have very little in common with the project under consideration. So moving forward, we finalize a first method or first tool. I will highlight also another one, which is the cost capacity factor, when it comes to the conceptual and the preliminary estimate of your project. The cost capacity factor applies to changes in size, in scope, or in capacity of projects of similar types. It reflects the nonlinear increase in cost with size, the economies of scale. Cost capacity factor can be accurate to plus minus 20%, sometimes 15%, of the actual costs, which is pretty also good. And this is the equation of the cost capacity factor. It's expressed by the following: C2 equal to the C1 times Q2 over Q1, all to the power of X, where C2 is estimated based on cost of the new facility that we want to build with its new capacity, Q2. And C1 is the known cost of the facility that's been built with its old capacity, Q1. And X here is the cost capacity factor for this type of project. Now for X is empirically derived cost capacity factor for a given type of project. And it is based on a very well documented historical records for different kinds of projects. As for Q, it is as Q2 and Q1, it is a parameter that reasonably reflects the size of the facility or the project, such as the following examples. If you have, for example, a Q for barrels per day produced by a refinery, tons of steel per day produced by a steel mill, or could be gross floor area for a warehouse. Let's take an example here to highlight by numbers the cost capacity factor.